So, good morning, students. I welcome you all for the second session of this subject, analysis of determinate structures. So, in session 1, we have studied what we mean by an arch, what are the classification of arches, then how to find out normal thrust and radial shear at any point on the arch. Now, let us start with the session by taking one a simple example. The example is like this: a three-hinged symmetrical parabolic arch has a span of 30 meter and central rise of 5 meter, subjected to a point load of 40 kilonewton at 10 meter from left hinge. Calculate reactions, and second one is normal thrust and radial shear at 12 meter from left hinge. Now, according to the problem, this is the sketch. So, three-hinged parabolic arch has a total span of 30 meter and a central rise h is equal to 5 meter, and this arch is subjected to a load of 40 kilonewton, and this load is at a distance of 10 meter, okay, at a distance of 10 meter from left hinge. So this is a left hinge. From 10 meter there is a 40 kilonewton load on this. So now for this for this arch we're going to find out first reactions, that is HA, HB, VA, VB, and similarly we have to find out normal thrust and radial shear at 12 meter from left hinge. So from 12 meter from left hinge, what will be the normal thrust and radial shear we're going to find out. So now let us start with this. I'll write step number 1. Okay, so what is step number 1? First we'll find out the reactions. Okay, we'll find out the reactions. So in that reactions, we'll first find out vertical reactions. Okay, we'll find out vertical reactions, that is VA and VB. Okay, so how to find out these vertical reactions? As you know already, so we are using the equilibrium equations. So first what I'm going to do here is taking moment of all the forces, taking moment of all the forces about any one support, okay, either A or B, but let us take moment of all the forces about A, and using the equation summation MA is equal to 0. Okay, take moment of all these forces about A is equal to 0. Now let us start with this point A as a reference. Now take moment of all these forces. As HA and HB are passing through point A, the moment of these two forces will be 0, and VA, moment of VA is also 0. Now let us have the moment of 40 kilonewton and VB with reference to point A. Now sign convention for this is clockwise moments are positive and anti-clockwise moments are negative. Let us take a sign convention. So with reference to A, first I will take a 40 kilonewton force. What is the moment of 40 kilonewton force? So 40 into 10 meter. So moment about A is equal to 40 into 10 meter. So with reference to A, this will going to produce clockwise. So this is plus 40 into 10 meter. Okay, then next we'll take a moment of VB. So what is the moment of VB? VB into 30 meter. So VB into 30 meter. So this will going to produce anti-clockwise. This is minus. So this is equal to 0. Okay, so from this equation we can find out reaction VB is equal to 13.33 kilonewton. Okay, 13.33 kilonewton. Okay, so we have find out the moment, that is the reaction VB. Now let us find out reaction VA. Now we're going to use another equation, equilibrium equation, that is summation Fy is equal to 0. So summation of all the forces will be equal to 0. So how many vertical forces? 1, 2 and 3. So again for sign convention, if the load is upward it is positive, if the load is downward it is negative. So now VA is positive, that is plus VA, okay, minus 40, then plus VB. Okay, 1, 2, 3. So this is equal to 0. Now VB is already known. This is 13.33 kilonewton. So from this equation, we can get VA is equal to 26.67 kilonewton. So VA is equal to 26.67 kilonewton. So this is what the vertical reactions. So remember, when you are finding out the vertical reactions, we have to consider the total arch. Okay, so total arch you can consider and use the equations. One summation moment about any one support is equal to 0, then summation Fy is equal to 0. You can find out VA and VB. Okay, now next we'll find out the horizontal reaction HA and HB. Okay, horizontal reaction HA and HB. Now what is the how to find the horizontal reactions? Horizontal reactions HA and HB. Okay, now for finding out the horizontal reactions HA and HB, you can consider only half portion of the arch. So there are two portions. Okay, so either you can consider the arch portion AC or you can consider the portion BC. So let us consider portion BC because there is no load here, so it will be easy to calculate the reaction. So let us consider the portion BC. So this is point B. This is another hinge at C. Now there will be a reaction, that is vertical reaction VB and horizontal reaction HB. Okay, so VB already we have calculated. This is 13.33 kilonewton. Okay, already you have calculated 13.33 kilonewton. Now let us find out this. Okay, join this and point C. Now this is I think 15 meter. Okay, so then central rise H is equal to 5 meter. Okay, now we have considered only portion BC. Okay, half of the arch. Okay, now again we're going to use moment equation, taking moment of all the forces about point C. Because C is also a hinge, we're going to take a moment of all the forces about C is equal to 0. That is summation MC is equal to 0. Again same sign convention. Clockwise it is positive moment and anti-clockwise it is negative moment. First we'll consider the force VB with reference to C. This will going to produce anti-clockwise. This is minus VB into 15. Okay, then with reference to C, this HB will going to produce clockwise. This is plus HB into perpendicular distance is 5. So this is equal to 0. VB already known, it is a minus 13.33 into 15 plus HB into 5 is equal to 0. So from this equation, you can find out the reaction HB is equal to 40 kilonewton. Okay, HB is equal to 40 kilonewton. Right. Okay, now we can use another equation, that is as you know, the in this arch. Okay, so always the horizontal reaction will be same, that is HB is equal to HA is equal to 40 kilonewton. So or because of due to symmetry, okay, HA is also equal to HB is equal to 40 kilonewton. Okay, or you can write HA is equal to HB is equal to, both are same, you can write H is equal to 40 kilonewton. Okay, okay, HA is equal to HB is equal to 40 kilonewton. So now let us write these values here. So VA is equal to 26.67 kilonewton, VB is equal to 13.33 kilonewton. Okay, then HB and HA are same, that is 40 kilonewton. 40 kilonewton. This is also 40 kilonewton. Okay, so this is the first step where we're going to find out the vertical reactions. When you are finding out the vertical reactions, consider complete arch, and when you are finding out the horizontal reactions, we can consider only half portion, either AC or BC. So this is the first step. Okay, now let us continue with the next. After finding out the reactions, horizontal and vertical reactions, next step is what they've asked here is find out normal thrust and radial shear. Okay, normal thrust and radial shear at 12 meter from left support or left hinge, at 12 meter from left hinge. Okay, so they have asked from the left hinge, you have to find out at a distance of 12 meter, okay, what is the normal thrust and radial shear. So for this we'll draw one more sketch. Okay, now I will mark this point as E. This is not a central rise. Okay, this is not the hinge. This is E, point E, and this is point D, and this is support A. Okay, as you already know, we have find out the reactions, that is VA is equal to 26.67 kilonewton, and this H or HA is equal to 40 kilonewton. Okay, and this, as it is given in the problem, you have to find out normal thrust and radial shear at 12 meter. So from support A, this will be 12 meter, and this vertical ordinate we don't know. We have to find out this vertical ordinate first. Okay, so now after drawing this, next we'll find out this ordinate first. Okay, but before this, finding out normal thrust and radial shear, we'll find out this vertical ordinate. So as you already know that, what is the equation of parabola? Equation for parabola is, that is any vertical ordinate on the arch y is equal to, okay, 4hx divided by L square into L minus x. This is the equation of parabola. Okay, or you can say that y is equal to 4h by L square. I will take this x inside. This is Lx minus x square. Okay, this is the equation of parabola. Okay, or which will going to give the vertical ordinate at any point. So now x is what? X is 12 meter now. So I'm going to substitute x is 12 meter. Then I can find out this y. Okay. Right. So we'll find out this y also. But before that, okay, we're going to find out. We're going to use the slope equation. Okay, that is slope equation. That is dy by dx. So slope equation dy by dx. So y we know, we are going to differentiate this equation, okay, with reference to x. So dy by dx is equal to what now? 4h by L square. So differentiation of Lx is L minus differentiation of x square is 2x. Okay, so dy by dx is equal to 4h by L square into bracket L minus 2x. Okay. Now, so dy by dx, we know that dy by dx is also considered as tan theta. So tan theta is equal to, okay, 4h by L square into L minus 2x. Okay, dy by dx is nothing but tan theta. So substitute here 4 into h is central rise, it is 5 meter, divided by total span, it is 30 square, into 30 minus 2 into x. X is, okay, 12 meter. X is 12 meter. So from this I can find out tan theta is equal to 0.139. So therefore theta is equal to 7.91 degree. Okay, so theta is 7.91 degree. So with this, with the help of this theta, now we can find out the normal thrust. Normal thrust. So first, as you already know that normal thrust is indicated as N. Okay, so this is equal to H cos theta plus V sin theta. Okay, H cos theta plus V sin theta. So substitute the values. N is equal to H, already we know that is 40. So before this, okay, let us write this is equation 1. So here we know H, we know theta, but we don't know V. What is V? V is nothing but the vertical shear or shear force at point E. Okay, so shear force at point E is equal to, first we'll find this shear force, that is V is equal to, what is the shear force? Okay, so what is the shear force here? Let us see. What is the shear force at point E? Shear force means addition of all the vertical forces. Now there will be two forces, that is one is VA, okay, one is VA, and another one will be, so there is a 40 kilonewton force is there. Okay, now if you want to find out the shear force at E, so add all the vertical forces. One is VA and another one is 40 kilonewton. Now for the sign convention for shear force, if the force is acting vertically upward, it is positive. If it is a downward, it is negative. Now according to sign convention, so it is a plus VA, okay, then minus 40. So this is a shear force at point E. So that is V is equal to, VA is 26.67 minus 40. So we can find out shear force at E is equal, V is equal to, now this will be minus 13.33 kilonewton. Okay, this is the shear force. Now substitute value of V theta in this equation 1. So therefore normal thrust N is equal to, okay, so H is 40 into cos 7.91, theta is 7.91 plus V is, it is a minus 13.33, okay, into sine 7.91. Okay, so after calculating the normal thrust N is equal to, okay, N is equal to, so we'll get 37.78 kilonewton. This is the normal thrust. It is nothing but a force, perpendicular force at point E. Now similarly the radial shear, the second thing what they have asked here, radial shear, it is denoted by, okay, Q is equal to H, okay, Q is equal to H sin theta, okay, minus V cos theta. We have seen already in the session 1. So the formula for radial shear is H sin theta minus V cos theta. So again substitute here, H is 40 into sine 7.91 minus V is minus 13.33, okay, into cos of theta is 7.91 degree. So therefore radial shear Q is equal to, okay, we're going to get 18.70 kilonewton. Okay, 18.70 kilonewton. So this is the radial shear and this is a normal thrust. Okay, so normal thrust is 37.78 kilonewton, radial shear is 18.70 kilonewton, and in the first step we have already found out the reactions. Okay, all the four reactions we have found out. This is what the analysis of arch. Okay, so I hope you understood this problem. So in the third session we're going to take some more problems and try to solve the problems. Okay. Oh, thank you very much. And if you have any difficulties or any clarification, feel free to call me. Okay. Thank you very much.